All right, next round. Number 11. Looks like I got to take a little integral here. What kind of integral is that going to be? Well, it looks like I've got some kind of algebraic thing and a logarithmic function. So I think it's time to roll out the liate. So that's first, and algebraic would come after that. So that means my u, and if you think, like, how do I know that it's this? I'm looking at this. This is a product, and integration by parts does kind of do product rule backwards. That's kind of what it's good for, right? The two different things. And this is not going to, a u substitution is not going to cut it here, right? If I make this the u, no, that's not going to work. If I make this a u, I don't have an x on the bottom. So after quick inspection, u substitution, regular style, ain't going to work. This should. So that means my u is the first thing I run into. The dv is the next thing. So antiderivative here, x to the 5th over 5. And derivative here, 1 over x dx. And integration by parts, the rule says that the integral u dv is equal to uv minus the integral v du. It's just like a rewritten version of the product rule. And so uv, looks like I've got x to the 4th over 5 minus the integral v du uv. So sorry, what did I do there? This is supposed to be uv. So that's natural log x times x to the 5th over 5. Sorry about that. And then the integral v du, there's my x to the 4th over 5 there. Just got ahead of myself. And I'm going to move down here, borrow some of this space. So, log, sorry, you can't see what I have up there. I'm just going to recopy this, minus the antiderivative of x to the 4th over 5. Knock the exponent up by 1, divide by the new exponent. All right, and this is a definite integral. I'm going from 1 to, there it is, 1 to e. So I've got my antiderivative now. So plugging in e here, natural log of e is 1 times e to the 5th over 5 minus e to the 5th over 25 minus, when I plug 1 in, natural log of 1 is 0, minus 1 over 25. So hopefully that's the same as one of those answers. Let's see if we can figure out if it is in fact. All right, here, it looks like we need to get a common denominator to match it up of 25. So multiply the top and bottom of that by 25, or by 5 rather, so that's 5e to the 5th minus 1e to the 5th over 25 plus 1 over 25. And that is the same as that one. Now that one slowed us down. That took almost 4 minutes to do that one problem. So let's see if we can pick up the pace. An object moves along a straight line, excuse me, so that any time t, its acceleration is given by this. Time t equals 0, the object's velocity is 10, and the object's position is 7. What's the position at time 2? Okay, so antiderivative of this gives me the velocity function plus c. So antiderivative of that would be 3t squared plus c. That's my velocity function. And I have a value, so I can solve for c. At time 0, the object's velocity is 10. So plugging, so velocity at time 0, which is 10, is equal to 3 times 0 squared plus c, so 3t squared plus 10. Right? And you could take the antiderivative again and find the c, Or you can go fundamental theorem on this right here and say, now that I've got the velocity function, I know that the integral from, I want to know about 2 and I know about 0. I know about time 0, want to know about time 2. Area under the velocity function, which is 3t squared plus 10 dt, is equal to position at 2 minus position at 0. Now, I like this way a little bit better, but you could have done another antiderivative and solved for c. Okay, so antiderivative of that is t cubed plus 10t from 0 to 2. That's equal to x, the position at time 2, that's what I'm interested in. The position at time 0 is 7. So this integral here, that's 8 plus 20. Plug in the 0, you get 0 plus 7. So it looks like we got 35 there for number 12. That's answer choice D. The graph of a differentiable function f is shown above on the closed interval from -4 to 3. How many values of x in the open interval satisfy the conclusion of the mean value theorem for f on the whole interval? So the mean value theorem is the one that says the average slope, which would be the slope of this line connecting those, actually happens. If the function's differentiable, then there must be points in that interval that actually have the slope of this average one. And there's 3 of them. You can see them. Every time, if you kind of tilt it this way, here's one way of looking at the mean value theorem. If you look at it this way, they're like maximums and minimums relative to this. Kind of like if this was 0, they're like the horizontal tangent lines. But they're not really horizontal, they're just parallel to that, right? But it's kind of like the same thing. That might help you see them. So there's 1, 2, 3. That's D. Don't want to spend too much time spinning your wheels on a problem like that. All right, what's the antiderivative of this? Looking at the answers, obviously this is a Taylor series problem. So the series for the sine function, sine of t, is equal to, or x if you want, whatever, t minus t cubed over 3 factorial plus t to the 5th over 5 factorial, etc. So if I plug in t to the 6th here, that means the sine of t to the 6th is replacing all of these with t to the 6's minus t cubed to the 6th is t to the 18 over 3 factorial, and so on. And then the antiderivative of that, as antiderivative of this would be t to the 7th over 7 minus, this would be t to the 19 over 19 times 3 factorial. And oh, there it is. I was like, where's my answer? There it is. It's D. Notice I started working with just 2 terms there. As if you look at these, none of the first 2 terms, none of the answers have the same first 2 terms. So don't need to go past that. All right. That was, I think, easier than it looked. Got to know the big 4. Speed of a runner in miles per hour on a straight track is modeled by this. Okay, so this is kind of weird choices. I might rename these things because I don't like it. The speed of a runner is modeled by, I'm going to call this S for speed, where M is the runner's distance in miles. Okay, so this is how many miles they went. I'm going to not call that F, I'm going to call that S for speed. So you plug in a mile, and then this tells you how fast they're running. Okay, I can handle that. What's the maximum speed of the runner from 0 to 3? And we don't have a calculator, so I guess we got to do this by hand. So if I'm going to find a maximum, I got to find S prime of M and set it equal to 0. That's just a constant. Derivative minus 6m plus 18m minus 12. Derivative, that's 0. So I need to know where this is 0, and this is going to go from the zeros that this has. This is an upside down parabola, so my S prime sign chart, it is going to go from negative values to positive values to negative values, and we want to know when it's a maximum, and that's the second one. So we'll see if they're both positive. We're definitely looking for the bigger of the two zeros. So I'm just going to try to factor this thing. I just need to take this thing and set it equal to 0. That doesn't matter. I'm going to take the negative sign out. I'm going to take a 6 out. So negative 6 over 10 if you want. You can leave that there. I got m squared plus, minus 3m plus 2. That factors into m minus 2. M minus 1 is the second one here. It's at m equals 2. But they want to know what is the actual maximum speed. So I've got to take that and plug it back into this thing to find that maximum speed. Not plug it into this. Plug it into that. They want to know what is the maximum speed. So plugging that back in here, I've got 1/10 times, what do I plug in? 2? Negative 16 plus 36 minus 24 plus 7. So let's see, that gives me 20 minus 24, that's negative 4. That's negative 0.4 when you multiply by that, and then add 7. So that's equal to 6.6. That's B. And I'm looking at my answers next to me, and that's not right. It's supposed to be 7. Oh, crap. You know why? Oh, why? What did I forget to do? What did I forget to do? I can't believe it. After all we've been through. What did I forget to do? I forgot to check the endpoints. All right, so let's check the endpoints. Well, if you're smart about this, when it gets to m equals 3 here, it's going down there, so it's not going to be this endpoint. So I just have to check 0. When I plug 0 into this, everything disappears. It's 7. They were going faster at the start. That makes sense. They're getting tired. Sorry about that. Forgot to check the endpoint. That is another maximum there. Second wind or something. Dough. No perfect score for me. Which of the following could be a slope field for this differential equation? Okay, so this differential equation, the x's, for x values, we're squaring them, so let's see, let's go by quadrant and see if we can figure it out that way. So in the first quadrant, when x and y are positive, all the slopes would be positive. So that eliminates this answer. These ones are all cool with that. In the, let's see, the second quadrant, the x values are negative, but they're getting squared in the y values. So all the slopes in the second quadrant would be also positive, because all the y values are positive, and all those negative x values, which we're squaring them, so that would all be positive. And I think that actually eliminates these two. So that was a good way to do it, right there. You could check a couple slopes just to see if you wanted to. Like if you plug in the point 1, 0, you get a slope of 1. That looks good, right? Plug in the point 0, 1, you get a slope of 1. Negative 1, 0, yeah, because the negative 1 gets squared. And then down here, 0, negative 1, finally get, yeah, so that's good. D. I think that's a good way to check those. Spot checking points kind of takes a long time. Doing the quadrant check is maybe easier. Hey, if that doesn't smack you in the face and say partial fractions, then, well, you better get some more sleep. Looking at those answers, it's very clearly the kind of answer we get when we're doing partial fractions. And they even factored it for us. Can you believe that? So a over 2x minus 1 plus b, x plus 1. So doing the little cross-multiplying thing, 2b times x minus b. So that's all got to be equal to 8x minus 10. So that means a plus 2b, a plus 2b must be the coefficient of the x. And a minus b must be equal to negative 10. So however you want to do this, I'll flip the signs of the second equation like so, and then add them together. That gives me 3b equals 18, b equals 6. If b is 6, then a is equal to negative 4, right? So this is negative 4, this is 6. Now let's go ahead and take the antiderivative of this new improved version of this. So the negative 4 is a constant. The antiderivative of 1 over 2x minus 1 is natural log 2x minus 1, but it had a 2 on the inside, right? So when I do that u substitution, I'd need a 2 on the inside, a 1/2 on the outside, so don't forget about that. Plus, I don't need to worry about that here because there's no multiplier on the x, plus 6 times the natural log of x plus 1 plus c. So negative 2 looks like answer choice B. And look, there it is. There's the choice if you forgot that little thing. Man, that's a bummer. Don't mess that up. There's a multiplier there. All right, number 18. What is the slope of the tangent line to this polar curve at this point? Slope of a tangent of a polar curve is dx d theta over dy, just kidding, dy d theta over dx d theta, because that's dy dx. So I need to find x and y, and I know that for polar curves, x is equal to r cosine theta. Don't know why I made that mark there. And y is equal to r sine theta. So I got to take the derivatives of these things and then put them over each other and plug that in. So this is not going to be pretty no matter how we slice it. So let's just get busy here. I'm just going to leave them like this and do the product rule. All right, so dy d theta, this first. Derivative of the first is negative 2 sine theta. That's 0. Times the second. Plus the first. Times the derivative of the second. That's my product rule there. That's dy d theta. Right, dx d theta. The derivative of the first times the second plus the first times the derivative of the second. We're plugging in pi, so probably a whole bunch of things are going to turn into 0. You could look for trig identities and try to get all fancy here, but I don't think the payoff is there. I think we should just start plugging stuff in. Sine of pi is 0. So this whole term is gone. Cosine of pi is negative 1. So this gives me, that's negative 2 minus 1. And cosine of pi is still negative 1 over here. So on the top, I've got negative 3 times negative 1, or positive 3. So some hopeful looking answers there. And then here, the sine of 0 is 0, so that wipes that whole thing out. And the sine of, oh look, the sine of 0 here is also 0, so the denominator is actually all equal to 0. So the slope is undefined, the limit does not exist. Let's look back at this for a second. You know, the other way you could have done this, I suppose, is you could have thought about what this polar curve looks like and then tried to do this. And then actually look at it and see what the slope is. I'll let you go back and do that, but I think this is some kind of cardioid or something. So if you like made your little chart of what's going on with thetas and r's, and you figure out what this looks like, maybe just really super quickly try that. Cosine of 0 is 1, so it starts out at 2, and then when you get to pi over 2, cosine of pi over 2 is 0 minus 1. What? So it's going from 1. How the heck is it doing that? I guess it's going like this. This is some sort of, yeah, I don't know how much time. I'm trying to do this in the time that you'd actually have to do the exam, so I don't know how much I want to go down this rabbit hole here. Let's see, so I guess when, no, it's going to go through that, isn't it? Because when theta is equal to pi over 3, the cosine would be equal to 1/2, so this would be equal to 0, and then it comes down to when cosine is pi over 2, when you're looking up at pi over 2, that's when this is 0, right? And then it would be -1, so somehow it gets down to here. And then what does it do from there? I'm curious now, I can't let it go. All right, so then when then we get into the negative cosine values. So as I look here, like more negative stuff. And when I get back to cosine of pi, when I'm looking this way, cosine of pi is -1, so I'm at -3, so when I look at this way, like I'm all the way out here. So is it some kind of big thing like this? Well, anyway, I don't think this was too helpful for this, but when you're at pi, I think there's your tangent line there. So it's undefined. So maybe this way was better. Some old big limacone. All right. Hey, that just, I don't know what you think. Come on, take a whiff of that. Does that not smell like the definition of the derivative? Well, it is. It's the x minus c one, right? This is f of x minus f of c over x minus c. But hey, you don't like that? Then bust out some L'Hopital's rule on this thing. So e to the 20th minus 3e minus e to the, so that's 0. It's 0 over 0. So L'Hopital, that's 20x to the 19 minus 3 minus, that's all just a number. That's gone. Over 1, plug in e, and there's your answer right there, b. That's a super easy L'Hopital problem. Or you recognize that it's this. And you're like, oh, well, this is the f of x, and it's the definition of the derivative. Then the derivative of this is that, and you plug in the e. Either way. What's the radius of convergence for this series? If we want to know the radius of convergence, we've got to do the ratio test. They're asking for that radius of convergence. This just came up for us recently. So ratio test says I need to find the limit as n approaches infinity of the n plus 1 term two times n plus 1 is 2n plus 2. Right? This is like odd numbers because you the next odd number. And then I'm going to divide by the original thing, x minus 5 to the n to the n plus 3 squared. All right, I'm going to try to simplify here. All of these x plus 5s cancel out everything except for just the last one of those. And that does not need to be inside my limit. And let's see, I've got a whole bunch of 2's, but I've got one more on the bottom. So these are all gone, and there's one there on the bottom. And then I've got 2n plus 3 squared and 2n plus 5 squared. So if you FOIL these out, basically you have a 2n squared and a 2n squared. So those are identical top and bottom exponents. The coefficients are the same, but there is this extra 2 on the bottom. So this is equal to x minus 5 times 1/2. Right? So that's the thing that I need to be in between -1 and 1. So when I multiply here, -2, and you don't have to go any further than that, I think, to see, oh, the radius is 2. It goes 2 this way and 2 this way, right? From x minus 5. You can add the 5 and see what the actual interval is from 3 to 7, right? But that's a radius of 2 up, 2 down. Radius of 2.